All right, this video is going to talk about how to graph two of the reciprocal functions. If we understand how to graph the sine and the cosine, then graphing the secant and the cosecant shouldn't be any monstrous stretch, if you will. Basically, the idea is over at the left, we've got the different angle values, sort of those special values, right? Pi over 4 being 45 degrees, pi over 2 being 90 degrees, 3 pi over 4, again, basically counting every 45 degrees. So 135, 180, right, at pi being a perfect half circle. But again, we're going to graph these functions sort of with those x values, just working their way from left to right, not thinking about our unit circle too terribly much. So again, if we think about our cosine, a cosine normally, again, would start at its maximum. So again, let's say that this is 1 up here. I'm going to start at 0, 1. Then at pi over 4, we're going to be at about 0.707. So again, if we were really looking at this, about 0.7 all the way up here, right, going to be right about there. By the time we get to pi over 2 or half pi, we're going to be at 0. Again, we bottom out at pi. And again, every other tick mark here, we're going to hit those nice values of like 0, right, and 1 and -1. Again, the 0.707s help us as well, just slightly, right? We can get those points on there. Just to remember that this is going to be a curve, right? It's going to be sort of sloping downward or curving downward. Then we're going to be sort of what we call cup up, right? On this part, it would hold water. And then sort of cup down again, almost like we flip that over, right? And get this other portion here. Now, I'm going to graph a little bit extra on there as well, just to sort of let this curve remind us that it does keep going infinitely onward and forever, right? So we're going to curve down here. Again, we would be kind of going out that way. And then same thing over into the negatives. Kind of that same idea, right? We're going to be curving back up this direction. Now, in order to graph the secant, well, remember, the secant is just the reciprocal of the cosine, right? Secant's going to essentially be 1 over, right, all of those values that we're looking at. So basically the reciprocals, well, the reciprocal of 1 is just 1. So anywhere along here where we're 1 or -1, those numbers aren't going to change. So the nice part is for the secant, all of these maximums and minimums are going to stay exactly where they are. Okay? So all the highs and lows are going to stay exactly where they're at. Now, the reciprocal of 0, on the other hand, right, if we think of that 0 as sort of 0 over 1, well, if we take the reciprocal of that, well, very simply, that's not going to work out too well, right? The reciprocal of 0 would be 1 over 0, or basically come out as undefined. Right? So anywhere that the cosine was 0, the secant doesn't even exist. And what typically happens, why do we get an undefined value? What we're going to do is go ahead and put a vertical asymptote on our graph at those points. Okay? So I'm going to go ahead and grab a different color here. Again, anywhere that we would have been going through the x-axis right now, right, the secant can't exist, which is why immediately you can look at that and say, okay, well then that means we can't graph this same sort of shape anymore, right? Again, where the cosine was infinitely, a nice smooth periodic function, right? No breaks in the graph, just flowing kind of nice and smooth here. The secant has a whole lot of values that you cannot plot. And to help us with what the rest of the shape is going to look like, we want to look at those other values. So again, we didn't normally always need these values, but if you think about it, 0.707, right, the reciprocal of that is going to be 1 over 0.7. Well, 1 divided by 0.7 actually ends up greater than 1, or you actually get 1.414. Right, 1.414. If you remember, 0.707 was basically 1 over root 2, so this actually just became essentially root 2. And the same thing will happen at negative 0.707. Flipping that over, it's going to be a negative 1.414. So notice instead of values below 1 or above -1, sort of in between there, right, the range of the cosine being from -1 to 1, the secant is now going to be 1.414 at all of those values. Or where we were down here in negative, again, we're going to get points values at about -1.414. And what happens is in between each one of these asymptotes, we get something that looks somewhat parabolic. It's sort of like a parabola. It is boxed in, right? It doesn't infinitely extend outwards. But again, we're going to get a whole bunch of these sort of U shapes, if you will, in between the asymptotes, right? As smoothly as we can. This is still periodic. It still goes on infinitely, right? Those U shapes are just going to go from going up to down to up to down, and we're going to keep on graphing those forever. One phase is still 2 pi units apart. Notice if we went from the asymptote over here at the left, from x equals negative pi over 2 up to 3 pi over 2, right? It still takes essentially 3 asymptotes, 2 of those curves, because then again, a full cycle is going to be all the positive values and all the negative values before we repeat again and get all these positive values again. It takes an up and a down, right, to do a full phase or a full period of our graph. But again, that means that we're going to sort of be split in the middle also, right, by pi over 2 there. But again, that's that red line here, right? Those red U shapes along with the orange asymptotes, those are what the secant, again, is going to look like. A couple things to remember. The period of the secant, just like it was for the cosine, is 2 pi over b. And the first 2 easy asymptotes that I would kind of point out, the 2 things to sort of know here, the easiest 2 places to remember that the cosine equals 0, because it starts at a maximum, would be the first time that we drop down to 0 here. So x equals pi over 2. And I just find it easiest to find the next one by actually going backwards, to kind of drop back down this way, right? The next easiest place, negative pi over 2. And again, if you can find both of those, you can find the rest of the asymptotes along the way. Let's take a quick look at the cosecant. You'll notice that's already graphed on here. It's going to be very similar. Notice all the values on the table look very similar to what we did on the last screen. The difference now is, remember that the sine started at 0, 0, right? Then we went up to the maximum, back to 0, down to our minimum, back to 0. Your sine curve normally would have kind of gone this way, right? It's going to kind of be up here and down here. And that is sort of a way to graph this. If you wanted to graph the sine and then just sort of flip those U shapes over, it's not a bad way to go. A couple of things to remember about the cosecant. Again, period is still 2 pi over b. And the easy asymptotes this time, well, the easiest 2 places to remember that the sine equals 0, right, would be right at 0, 0. So again, right on the y-axis here, we would have had an asymptote, right? X equals 0 there. And then also the next time that we reach 0, again, would have been at pi, right? Would have been right here, right, in the middle of that sine function. So again, x equals pi, or 0 and pi. Easiest 2 places to find those first 2 asymptotes. Obviously, you could also find it 2 pi, but again, we don't want to skip that asymptote in the middle of our graph either. So again, remembering x equals 0 and pi. Those 2 things will be very helpful for us. Let's look at a couple of small details again. So remember, anywhere that the sine would have been 0, so talking cosecant, what we were just looking at, because the cosecant is divided, right, 1 divided by the sine, then basically the asymptotes will happen at pi n. If n is any integer, if n was 0, we get an asymptote. If n was 1, pi, x equals pi is an asymptote, or 2 pi, 3 pi, 4 pi, all those whole values of pi. And realize that'll happen for cotangent as well. There'll be a different video made, though, to talk about the cotangent. It looks a little bit different. So right now I'm thinking cosecant, though. Again, the first 2 places that the sine would equal 0 would have been 0 and pi. So the easiest way to find the asymptotes for a cosecant are to set that entire inside, normally what we call b times x minus c, right? Everything inside the sine, we'll set that equal to 0 and pi. For the cosine, on the other hand, again, the first 2 places would have been plus or minus pi over 2, or pi over 2, and then you could sort of plus or minus, right, a full pi, half period. Again, that works for the secant. It'll also work for the tangent. And again, they're going to happen at pi over 2, and then we add pi units, right, a half a period every time. And again, to find the first two easy ones. We're going to take everything inside and we're going to set that equal. I'll show you how that works here in just a second. We'll come back to that on that other video as well. Let's take a look at an example of where we have a little bit more going on, and I'll show you how I tend to graph one of these functions. So again, we're looking at the cosecant, which means the first thing I want to remember is that this is 1 over the sine of x. So let's go ahead and find those asymptotes. Let's do that right off the bat. That's a good place to begin our graph. So I'm going to grab everything from the inside here of my cosecant. So pi over 3 x minus 2. And I'm going to set that equal because the sine would have been 0 and pi, right, for our first two asymptotes. I'm going to set that equal to 0. And then I'm also going to go ahead and solve that equal to pi. All right. Now you can do that together if you want to. I'm going to go ahead and make a separate equation real quick, because those two things will happen a little bit differently. So again, the first thing I'm going to do is go ahead and divide by pi over 3. Now the nice part is 0 divided by anything. Oops. Let's go ahead and write that a little more smoothly here. X minus 2 then is equal to 0 divided by pi over 3 is still 0. And then if I add 2, my first asymptote then will be at x equals 2. Down here in the bottom, again, I'm going to do the same thing. I'm going to divide by pi over 3, which just means I get x minus 2 equals, again, the pi's will cancel, multiply by the reciprocal, we end up getting 3. And if I add 2, x equals 5. So again, there's a vertical asymptote at both of those numbers. So I'm going to go ahead and plot then 1, 2, 3, 4, and 5. I'm going to draw that first asymptote here and the second asymptote there. And now you'll notice, again, those asymptotes are 3 units apart. So if I went 1, 2, 3 more units, I could draw another asymptote. So x equals 2, x equals 5, and x equals 8. Again, that's going to be our first phase of our graph. Now after that, we want to find just a couple of major parts here. Now, we don't really need to find an amplitude, right, for our graph, but I do still need to know sort of where the middle is. So notice again, because this value right here is minus 1, the center of our graph, or sort of the equilibrium, is going to be down here at negative 1. Then, even though this is a 2, again, we're not really going to call it the amplitude, because again, it's not how high and low the graph goes. This is actually where the gap will be. So what I'm going to do is go ahead and from the equilibrium go up 2 units and down 2 units, halfway between those asymptotes, right? Again, these are the points where the sine would have been on the x-axis. In between those were the highs and the lows. So I'm going to go up 2 units and down 2 units for those. Now the easy way to remember is that from the first one, so where we found x equals 2, I would have gone upwards, so that's where we're going to be up top there. The second one would have been where the sine would have gone downwards, so down 2 units down here. Now although the sine would have sort of curved up here, right, and done that, the secant on the other hand is going to curve up and away from there. We're going to curve sort of up and away. And on the other end, sort of the same idea, down from that point, as symmetrically as we can. That's one full phase. Again, if you wanted to do more of them, we could go forward, although I'm a little out of room there, or we could go backwards, right, to find another asymptote here. And again, I could graph more of our graph, knowing that, again, I'll also be at the bottom on this one, again, graphing down, and then we would have gone upwards, again, over here, right? But again, those first two are the most helpful ones. Now, you can definitely still list off the period, never a bad idea, right? 2 pi divided by our pi over 3 here, right, would have come out to 6. And notice that, again, the distance between these is 6 units, right? From 2 up to 8, a full phase, one upward and one downward. If you have any questions about those graphs or you need some more information, make sure you talk to your teacher. Otherwise, have a great day.